All right, today we are going to take a look at the relationship between our variables, and we're going to start exploring different relationships between our independent and dependent variable. And more specifically, today we are going to look at our linear and non-linear graphs. So first off, we're going to take a look at some linear graphs. And linear graphs are simply called linear graphs because they form a line. They're the result of a linear equation. They form a line because they are the result of that linear equation, and the change of our independent variable gets a direct result from or in our dependent variable. They form a straight line in any direction depending upon the change to our x or y variable. Y changes directly because of the changes in x. They can go in any direction, but we will always get a straight line, hence the name linear graph, linear equation. The equation we can show you later in class, and it's not something that I'm going to require you to know at this time, and it's pretty basic algebra to pick up on. So those are a few different examples, a couple in the first quadrant of the 4-quadrant graph, and here's a couple examples showing you that the linear equation can go clear across all 4 quadrants of our coordinate plane. So a linear equation is a straight line going on forever. Okay, now let's go on to some nonlinear equations, or nonlinear graphs. Nonlinear graphs are called nonlinear because they show a relationship between independent and dependent variables that do not form a straight line. For example, this might show the amount of income that we would make based upon the price that we charge for a bicycle tour. Up to a point, we're going to make money because it's going to be cheap until we hit a certain cost where people are no longer going to want to pay, and then the number of customers will fall off and we will no longer make money. So that's going to give us a curve to our graph. Or the temperature of a day from midnight to midnight as the day progresses is going to be an arc. Or we can graph the number of people that get A's or B's or C's or D's on a test. We can kind of graph that, and the number of people is going to arc based on the test or the test type or things like that. So any of these would result in relationship between our variables that would result in a nonlinear equation and therefore give us curves in our graph. So we have these parabolas, these little bendy, and I forget the name of this exact one, but I was out searching, but you will actually get graphs that look like this in algebra. Here's a time and temperature where the temperature decreases down to a certain point, and it's not a straight line. It actually curves down. So these are called nonlinear because they do not form a straight line. So let's take a look at an example of some data to where we can maybe make a graph and decide if it's either going to result in a linear or non-linear graph. So here is a table from the book and prices that customers would pay. So our tour price is $100. It shows us that 40 customers would pay that, and so on and so forth up to $500. So I know that if I charged $100 that I would have 40 people show up, and that as I increase my price, the number of customers decreases. This is a relationship between price and number of customers, whereas the tour price here is my independent variable, or my x, and number of customers is my dependent, or my y. All right, so let's make a graph. All right, so let's go ahead and start graphing this. At 40 customers, we would have, or at $100, we would have 40 customers that would be willing to pay that price. So we'll put a dot here at 40. At 150, we would have 35. At 200, we would have 30. At 250, we would have 25. At 300, we would have 20. At 350, we would have 15. At 400, they would have 10. At 450, there would be 5. And at 500, there would be 0 people willing to pay that price. So if we were to connect the dots, which, again, we should probably connect the dots only if there's information that could be found, and that can be up to you. And of course, always use a straight edge when connecting dots. We kind of see this in, if I could draw a straight line, this would be a linear pattern here. This would be a linear equation, okay, which would be a linear graph. Okay, it is a decreasing linear graph. So as the relationship here would be as price increases, number of customers decreases. Okay, and this would be one example of a linear equation or linear graph. So we could add another line or another column to this, and we could figure up our income based on this. But here's a question I want to pose as we close out our video for tonight, or this afternoon, or whenever you're watching this thing is, what do you think our graph would look like if we added a column or row for income onto our table? Would that graph be a linear graph or a non-linear graph? Would income for our business be a linear graph or a non-linear graph? Would income be related in a linear fashion or a non-linear fashion to the price that people would pay for a bicycle tour? All right, I'll see you tomorrow.